Hi there, students, and we're going to continue our practice with linear functions here. Here we've got slope is equal to m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. You will notice that I'll use sometimes the terminology y2 or y1, or I'll use the terminology y sub 2, y1. So these are interchangeable vocabularies. So we can use both without any kind of real problems coming up. So I want you to use this formula to find the slope between the given set of points. So we've got negative 3, 8 and 2, 4. Okay, I want you to pause the video here and give it a shot. Now, it doesn't matter which one of these I say is my first set of points, which is my second set of points. What's important here is the list that we make for our different x and y values. So my y2 is going to be 4. My y sub 1 is going to be 8. My x sub 2 is 2. And my x sub 1 is negative 3. So remember, for these different ones, if I'm looking at my first point, if I'm looking for the x1, I go to my first set of points and it's x value. If I'm looking for y sub 2, then I go to my second set of points and I look for my y value. So now we're going to substitute this into our equation. So I get slope is equal to 4 minus 8 divided by 2 minus negative 3, just using the bracket to help keep things tidy. And I get negative 4 over positive 5. So that's negative 4/5. So let's show that we get the exact same thing even if we changed around who we thought was first and who was second. Ooh, that 4 didn't come out too well. So this time I'm going to think of this as my second point, this as my first point. So I'm going to make my list again. So y sub 2 this time is 8. Y sub 1 this time is 4. X sub 2 this time is negative 3. And x sub 1 this time is 2. So substituting this into our equation, we get slope is equal to 8 subtract 4 over negative 3 subtract 2. And this gives me 4 over negative 5, which again simplifies to negative 4/5. And there we have it, the slope between 2 points. Now the last skill that we're going to take a look at today is using, once again, points and slope. We can use the relationship between points and slope to determine missing values of x and y. So here's your example. You have the points 2, 8 and negative 5, y. We don't know what y is, but we're told that this satisfies a linear function with a slope of 3. We want to determine the value of y, which makes this statement true. So there's two things to kind of bring into context here. First of all, when I talk about a slope of 3, usually slope is written as a fraction. So I can think of this as 3 over 1. Anytime you have an integer value, you can always make it into a fraction by giving it a denominator of 1. The next thing is that this value y is what we're trying to solve for. Our goal is to find out what value makes this true. So we're going to start off by simply making a list. I'm going to call, let's say, this my first point, this my second point. So I want you to pause the video here and make your list of values for y1, y2, x1, x2. So let's see what you've got. So for y sub 2, well, we just get y. And for y sub 1, we get 8. For x sub 2, we get negative 5. And for x sub 1, we get 2. So we're going to put this into our equation. So I know what our slope is. Our slope is equal to 3. So I get 3 is equal to y subtract 8 divided by negative 5 subtract 2. So our next step here is we need to simplify. So I'm going to have 3 is equal to, well, y and 8 can't simplify because they're different objects, but negative 5 take away 2 is negative 7. So now we're into solving mode. So you recall from grade 8 and grade 9 is that to get rid of something in the denominator, we multiply both sides by the denominator. So I'm going to multiply both sides by 7. You can think of it as 7 over 1 if that helps with the fractions. So what am I going to get? So negative 7 times 3, this is negative 21. And now we're going to use a little bit of cancellation here. So this negative 7 reduces out with this negative 7 to just give us 1 over 1. So all that we're left with here is we're left with y subtract 8. So now the next thing I want to get rid of is my constant term. To get rid of this guy next. So I have to get rid of negative 8. And the only way to do that is to add 8 to both sides. And now I'm going to be left finally with negative 13 is equal to y. So the y value that makes this statement true is negative 13. And let's check to see if our answer is correct. So we said before that we can think of a slope of 3 as 3 over 1. So I should get the following. I should find that 3 over 1 is the same as putting our y value in. I should get negative 13 minus 8 over negative 5 take away 2. So all I did is I just put in this original, but I substituted the value of negative 13 in for y here. So all we're going to do is we're going to go through and we're simply going to simplify. So I get negative 21 over negative 7, and negative 21 divided by negative 7 gives me 3 over 1, which means that our answer is perfectly correct. So a little bit of fun algebra for you. So we're going to take a look at another example along the same lines here. Oh, and I just want to change this one up a bit. Instead of a slope of 3, let's make things a little bit more interesting. Let's have 2/3. There we go. Now it's interesting. So we've got the points x comma 0 and negative 3 comma negative 6. And this satisfies the linear function that has a slope of 2/3. So I'm going to determine the value of x, which makes this statement true. So again, we're using our equation. Slope is equal to y2 minus y1, all divided by x2 minus x1. So to help us out here, we're going to call this 1, this 2. So first thing I want you to do is pause the video, and I want you to make your list of y1, y2, x1, x2. So what we find is that y is equal to, y2 is equal to, in this case, negative 6. y1 is 0. And don't let the fact that y1 is 0 phase you. 0 is just a number, has a few special properties like you can't divide by it, but it doesn't, don't let it freak you out. x2, in this case, is negative 3. And x1, well, that's just x. It's our unknown. So we're going to substitute these values in here. So for m, I have 2/3. And for this lovely bit on the right, I get negative 6, subtract 0, all divided by negative 3, subtract x. So first step, same as before, don't let it freak you out. We're going to simplify first. So I can simplify each part. 2/3 doesn't simplify, but negative 6 take away 0 is the same as just negative 6. And then on the bottom here, I get negative 3 take away x. Okay, so this is the point where you might be really worried, like, what do I do? What do I do? So remember the suggestion from the last question. When you have something in the denominator you want to get rid of, we want to get this out of the denominator. Well, what do? Well, I multiply both sides of the equation by it. So I'm going to multiply both sides of my equation by negative 3 take away x. And negative 3 take away x. Now, if it helps to think about it, you can think about it as over 1. And let's see what we end up getting. So I'm going to use the distributive property here. 2 multiplies each one of these guys in here. So I get negative 6, take away 2x, over 3 is equal to, now the nice thing is, at this point, this big piece here reduces out with this big piece here. I mean, that's why we multiply by the denominator, so it reduces out. So the right-hand side simplifies right down, and we just get negative 6. So now, we're going to do the same trick again. We have something in our denominator. Fractions make things more difficult. So I'm going to multiply both sides by 3. So I'm going to multiply both sides of my equation by 3. What that's guaranteed to do here on the left is this is going to reduce with this to leave me something really nice. On the left-hand side, I just get negative 6 take away 2x. And on the right, I'm going to get negative 18. So from here, we're going to solve by taking out this negative term. So if I need to remove a negative 6 that's being added, how do I do it? Well, what I'm going to do to both sides is I'm simply going to add 6 to both sides. And we'll simplify and see what we get. So I get negative 2x is equal to negative 12. Now I need to get rid of my coefficient of negative 2. So negative 2 is multiplying x. In order to get rid of a multiplication, we do its opposite, which is division. Divide both sides by negative 2 and simplify once again. And we find that x is equal to 6. So here's our answer. And what we want to do now is we want to check it. That's the beauty of algebra. Always remember, you can check your answers in algebra. So I'm going to have this original equation again, but I'm just going to substitute in 6 for x. So let's move it up so I get a little bit more room. So I want to see, is it true that 2/3 is equal to negative 6 take away 0, all divided by negative 3 take away 6? So we're simply going to simplify. So I get negative 6 over negative 9. I can divide each one of these by 3. And a negative divided by a negative is positive. And I do indeed get 2/3. So this is correct. So this means that our answer is x is equal to 6. And these are some of the harder examples that you're going to come across.